So as we talk of the voltage divider bias common emitter amplifier, we are going to notice that this is simply one and the same as what we had before, working with the fixed bias common emitter amplifier that had the emitter resistance and the emitter bypass capacitor. Remember, we talked about this when this resistor was not involved. We're just considering our RB and our RC. So this time, we are going to notice that you'll be having a voltage divider. So RB1 and RB2 are for the voltage division. That part is for the voltage division. With our RC, our RE, and our CE at the emitter there, meaning to say, still we are going to talk about the emitter voltage that is going to be there, our base emitter voltage, that part is not going to change, guys. Our collector emitter voltage, everything is going to remain as it is. The only part that is affected or that has changed is the voltage division. So in that voltage division, we are going to notice that it can now be calculated as, so on our calculations, only part that we are going to consider now is the part of the voltage division. So this is the part that is going to affect us. That is, we can calculate the value of RB1 of the voltage division. That is the voltage divider resistors. So for the voltage divider resistors, we have got RB1, which can be taken from the formula RB2. So it's going to be RB2 into VCC minus VB. We never talked of the VB before. So meaning to say there is a need of us to talk about this VB that we are seeing, which is referred to as the base voltage. That is the one that is just affecting the base, not VBE. No, not VBE. This is VB. So VB can be calculated if you are given the value of VE. Remember, you can calculate from VE. You can calculate the value of VE. We talked about this in our previous class. Plus VBE. You'll be given the value of VBE. You can calculate it from this formula. You can calculate it from the formula when you are given the value of this RB2. So it's going to be RB2 over. We are simply making the subject of the formula this VB that we are seeing inside. So it's going to be RB1. So it's going to be RB1 plus RB2 times VCC. It can be given like this. Okay. So, but the major part that I need you to understand is this part and this part, because you'll be given that from your formula sheet. You'll be given, they'll provide this formula. They'll also provide this formula for you. Also on this part of our voltage division, on these voltage divider resistors, we can see that we also have RB2. So RB2 can be calculated, which is part of the voltage division also. So RB2 is stated to be 1/10 of the current gain times RE, which is our RE. Okay, just write it as RE like that. No problem. Which is RE is our emitter resistance, that part of RE. We talked about this from our previous class. So this is the major part that is only changed from our simplification. This part here is the only part that we have to consider, this part. Otherwise, all those calculations that we had before, other calculations remain the same. So the rest of the calculations remain the same. So other formulas remain the same. So as you are to consider the other formulas, which formulas are we talking about? Remember, we talked of calculating of the emitter resistance, which is RE, from VE over IE. But I said that this IE is equivalent, approximated to be equal to IC. So we can take this as VE over IC. Remember that part of IE from the concept that IE is approximately equal to IC. So we can use that as a concept for calculating of this value of RE. We talked about this from our previous calculations. We talked about calculating VE. If you still remember, we said VE, it's 1/10 of VCC. We also talked about calculating the capacitance value, which is the emitter bypass capacitor, which is to be taken from 10/2 pi f RE. We also talked about this, which you're given from your formula sheet. We also talked about calculation of the RC. What is going to happen here is, guys, the only part that has changed is on RB. RB is no longer considered to be only RB. There is now a voltage division. So RC is not affected. The same way that you're calculating your RC, this one is not even affected. Okay, remember you're subtracting VCC minus VCE minus the VE that we have on the RE there. Then you divide by what? IC, the current that is flowing on that resistor. So RC can be calculated from that previous formula that we used to have VCC minus VCE minus VE, everything over what? Everything over IC, where we have a relationship in terms of the currents. Sometimes this IC and IB, remember from your current gain, that beta is equal to IC over IB, which I said you might be given from your textbook. Maybe they can give you in terms of IC being equal to beta times IB. Guys, it's how you're given. It's how you're given. So these are the formulas that you will need as long you are to talk of a voltage divider bias. A voltage divider bias common emitter amplifier. So as we consider your formula sheet, you are given these, okay, for your voltage division, your RB1, okay, your RB2, 1/10 beta RE. We are no longer using this RB. You remember, use this RB when you were just dealing with a fixed bias common emitter amplifier, just a normal one, when you are given that emitter part. But this time there is a voltage division, so you consider RB1 and RB2. Then RC is not going to change. When I take your RC as it is, you also saw that the VE, all these part of the beta, the calculation of the CE is not gonna change, even if we are to talk of what the part of the RE is not affected. The only part that we are now considering is this. And also I talked about this VB, that VB is equal to what? VE plus VBE. So these are the calculations that you need, except for this one. This one is not going to be there. As long you are dealing with the voltage division, these are the formulas that you need. So as you can see, some of the formulas, you considered them before. All right, so let's check how questions can be given pertaining this type of our bias, transistor bias that we are given. We are given the following data for the fixed bias amplifier in Fig 1.4. Yes, it's a fixed bias, which we do understand, but what type of a fixed bias? It's a voltage division in Fig 1.4. This is our Fig 1.4. So that we are talking of what? The voltage division. So from there, we are given the values of VCC, current gain, IC, VC, and so on, the frequency. Use the above information and calculate the resistive values of, you are given to calculate the resistive of what? RB1. So you need to calculate RB1, RB2, RC, and also CE. Okay, the CE and RE. Okay, so this one is RE. So you need to calculate all these. Use is made of silicon. Resistor and VBE may be used as 0.7 volt. VBE can be taken as 0.7 volt. That's what you're given. So the question is, how are we going to obtain? How are we going to obtain this? Okay, we check RB1. We can see that there's a lot of things there that you need to consider from RB1. So let's start with RE. I think RE, there's fewer things to consider there, VE and VC. Okay, let's just talk about this. Just start with that one. It's up to you guys the way that you're going to take them. Okay, each and every part, if there's something that is missing, you have to calculate that. Okay, so number one, just going to start with this RE. It's easier to have the emitter resistance. We saw that this can be obtained from VE over IC from that approximation part that they are approximately the same. So you can just take VE over IC. Okay, let's check. Are we having this? Are we having VE? Are we having IE? VE we do not have, but IC, which is same as IC, this IC, this one is given, okay, which is the same as what? IE. So we do not have this one, but we have IC. So how can we calculate VE? VE can be calculated. Remember, VE is what? 1 over 10 of VCC. So we can calculate VE from there because this is 1 over 10 of VCC, or simply VCC over 10. So VCC is given, which is 15. So we're just going to divide, or just multiply by 1 over 10. 1 over 10 times 15, that was going to give us the value of VE, which is 1,5 volts. So we have got VE. So to calculate RE, we're just going to substitute, okay, because we've got VE, which is 1,5, and IE, which is same as IC, is the one that you're going to use. So you're going to use IC instead. The collector current 5 milliamps, 5 milliamps times 10 to the exponent of -3. So that was going to give us the value of RE, which is our emitter resistance. From this, we're going to obtain 300 ohms. So you've got the value of what? You've got the value of RE from there. So that is the condition. Remember your approximations of all these formulas. Okay, let's check CE. Since we have RE, we can calculate CE. It's easier for us to now calculate CE. Remember, CE is just given from your formula, 10 over 2 pi FRE. So we're just going to substitute into our formula, all right, to calculate this CE. So let's just remove this part, guys. We have calculated in case that you need it. VE, let's just write it aside. VE is equal to 1,5 volt in case that you will need it. All right, so let's check. Remember, we want to calculate CE. Okay, just gonna move on and have this number 2. CE, we saw that CE can be calculated from the formula 10 over 2 pi FRE, like this. So meaning to say, that's the capacitance value. And as I said, it will be easier because you know that you're calculating capacitance and measuring capacitance in microfarad. You can simply multiply by 10 to the exponent of 6 your answer, so that your answer will be automatically in microfarad. Okay, so whatever that you're going to get, just multiply it by what? 10 to the exponent of 6. It was going to give you 88,419 microfarad. So as you can see, because there we have nothing that has changed. Some of these values, we had them before. So you might say, okay, these values I calculated before. Okay, also the RC, these ones, they are not going to change. The change is just on RB1 and RB2. Okay, RC, same formula as we used before. So our RC, remember, from the VCC minus VCE minus VE over IE. So we're just gonna have our formula and substitute because we've got all these values. Okay, so let's see. I'm just gonna have it here. So that's our RC. So we saw that RC can be calculated as VCC minus VCE. Then you subtract VE divided by what? The collector current. So that's the value of RC can be obtained. We have got these values. So let's substitute VCC, VCE. So you're going to have 15 minus 6. So that's 15 minus 6 minus VE. Remember, you calculated VE, you got 1,5. Then you divide to the collector current. Remember, your collector current, it was 5 times 10 to the exponent of -3, 5 milliamps. So that was going to give us RC, which is 1,500 ohms, or 1,5 kilo ohms. depending on the way that you want to have it written as. Then from there, you can also obtain the value of RB2, which you can see that it can be easier for us to obtain RB2 for the voltage division. Okay, so for the voltage division, just going to remove this part and same. It's easier for us to calculate that. Okay, so we're going to calculate RB2. So we saw that this is 1/10 of beta RE, which you're also given from your formula sheet. Like I said, if we check the part of our RB2 here, it's easier for us to calculate this. As you can see, RB1, you need RB2. So you must calculate RB2 first. Okay, so that means our RB2 was going to be 1/10 times our current gain, our beta, which is 200. So that's times 200 times RE, which is 300. So with this, you're going to obtain the value of the voltage division resistor 2, which is 6,000 ohms, or you can just have this as what? 6 kilo ohms if you divide by 1,000. So that's it. We have got the value of what? The value of RB2. So you must remember this because we are going to need this 6,000 ohms to calculate the value of RB1, which is the last value that you need there is RB1. All right, so to calculate RB1, we are simply going to use the formula. RB1, we saw that it's given as RB2, this one. That's RB2 into VCC minus VB, everything over what? Everything over VB. So in this case, we have got this. Remember, we just calculated this. This is the one that we got as 6,000 ohms. VCC is given, but we do not have VB. So how can we calculate VB? If we have got VE and VBE, we can see that our VB here can be calculated. That is, VB is given as VE plus what? VBE. So from there, we are going to have our calculations. All right, so let's calculate this one aside. So we saw that VB can be calculated from VE plus VBE. So it's a matter of joining the formulas in order to obtain what you're given. The VE is already there, 1,5. Then the VBE, you will be given this value, 0,7. So that's you're given as to use 0,7 for a silicon. So that means our VB was going to be 1,5 plus 0,7, which is 2,2 volts. Having the voltage VB, it is going to assist us to calculate the value of RB1. RB2, remember, we already have this value. We calculated and got 6,000 into VCC, which we are given. Our information, VCC is what? 15 volts. So that is 15 minus VB. What is the value of VB? Our VB is 2,2. And there you're going to divide again by the same VB, this one, which is 2,2. That was going to give us the value of RB1, which is part of the voltage division combination that we have there. So it was going to be 34,909.091 ohms, which you can write in kilo ohms. So you can actually have this in what? In kilo ohms. So RB1, just divide by 1,000. It was going to be 34,909 kilo ohms. So thus you can have your answer that way. So these are the typical questions that you can actually be given considering the part of our voltage divider bias common emitter amplifier. So let's see how typical exam questions might be given, as we have got this question, question number 3 on our transistor amplifiers. The first part that we are given, as you can see, was actually 8 marks. This first part only, where you just need to apply these formulas only in exam. You can see that that's a lot. So there you are given 3.1, the following values of common emitter amplifier. It's very true that it's a common emitter amplifier, but what type are we talking about? Is just the normal one that we are used to, or is it of a voltage division? So you see that you are given IC max, RE, beta, these ones, and VB. Just having this VB tells us what we are talking about, because the VB that we are having is found when we are dealing with what? The voltage division. So this part, and also these, calculate the following, guys. Check RB1, RB2, this one. This is part of voltage division. We do not have this on a normal fixed bias common emitter amplifier. But once we have RB1, RB2, we're talking of what? The voltage division. So we are back to this part of our voltage divider. So this one, it was going to lie under a voltage divider. So that's a voltage divider, common emitter amplifier that we have, the voltage divider. So we are back to the same formulas, guys. Nothing has changed. So the question was to calculate VCC. Okay, we never had a formula to calculate VCC. No, we never had a formula to calculate this VCC, but VCC can be found from other formulas. Okay, it's unfortunate that maybe here we have removed some of those formulas due to the calculations that we're having here. But you can see that I'm going to check, I'm going to take you to the formula sheet so that you can see properly. You will see that where the VCC is, one, there is this part where VE is and VCC is there. And there is this part where there's a lot of things that you have to consider when you've got RC. Okay? And this, from VE, the question is, can this VE be calculated? Maybe if there is IC or RE, we can think of calculating that VE, or maybe if there's a VB and a VBE, because there's a relationship that is there. All this part VCC is there. So we must think along which part that we can actually have that can bring this VCC. All right, so let's start with the first part that we are given, where the VE is related in terms of what? In terms of VCC. We saw that VE is given as 1/10 of VCC, which can be easier for us to make this the subject. So how can we make VCC the subject? Just going to multiply by 10. As you can see, this 10 cross multiply with it, or just multiply by 10 both sides, so that we have got the VCC that we need. So it means that VCC was going to be 10 times VE, which is 10 VE. But we do not have this VE. We do not have. Where are we going to have VE from? If we are given RE, VE can be calculated, but we still have a limit there, because it states that VE can be calculated, remember, from RE. Let's say for RE first, from the way that we usually given. I said this is VE over IE, but IE approximates to IC. So you're going to just use this as IC. So VE is there here. So you can make VE the subject. So VE is going to be cross multiply. So it was going to be IC RE. This is where we are. We need IC, we need RE. Okay, so let's check. IC is there, RE is there. So you can use these values, guys. IC and RE, we have these ones. So we can calculate the VE that we want. We have this. So what is the value of IC? 10 milliamps. 10 times 10 to the exponent of -3 times RE, which is 120. So that was going to give us the value of RE, which is 1,2 volts. With 1,2 volts representing our VE, we can now calculate the VCC that we want here, because it's 10 times VE. And VE is there. We have it, 1,2. So let's multiply. We're going to have our voltage. So that's our VCC was going to be 12 volts. So you see, exam, we have to think along the formulas that you are given, manipulation of those formulas to determine or have whatever that you're given there. It's not like you're always going to be given these as direct. No. This is exam. So for 4 marks, that's it. Let's consider 3.12. On 3.12, you are given now to calculate RB2. And from our calculations, RB2 can be calculated. We saw that this can be calculated. RB2 is 1/10 beta RE. So that is, we're just going to substitute. Okay, everything is there. Okay, let's see. We need RB2, which is part of the voltage division. So we saw that RB2 can be calculated from 1/10 times beta RE, which is our gain. So that's 1/10 times the beta, which we are given as 250. So that's 250. RE is 120. So all these values, guys, we have. So multiplying this, you are going to obtain the value of RB2 from this one. And that was going to give you 3,000 ohms. And 3,000 ohms is just same as 3 kilo ohms. You can even write as what? As 3 kilo ohms. It's up to you. That is your simplification. You can just leave it like that. That is our RB2. What about RB1 on 3.13? So on 3.13, they need us to calculate the value of RB1. Okay, again, if you've forgotten this, your formulas, they are there. So you saw that RB1 can be calculated from RB2 as RB2 into VCC minus VB over VB. Remember that part of VB that you are given, that I was saying that you must consider to say, where are you given VB? It's part of the voltage divider. So along the information, well, they're not going to or tell you that this is a voltage divider that you are given. No, you're supposed to know by information that you're given. So we saw that this is going to be RB2 into VCC minus VB, everything over what? Over VB. So just going to substitute. We have got everything, guys. Remember everything. We calculated the VCC, everything is there. So that's RB1 was going to be RB2, which is the value that we just calculated now, which was 3,000. So that is 3,000 into VCC. Remember, you calculated this. This is 12 minus VB. You are given the value of VB, which is 1,8. If you still remember here, 1,8. You're given this. That's 1,8. Then you're going to divide by that same value of 1,8. That was going to give us the value of RB1, which is part of the voltage division resistors. So that's it. And this was going to give us 17,000 ohms, which is same as what? 17 kilo ohms. So this is how your questions might be given, just considering the part of the voltage division on its own, just the basic calculations. Then we're going to talk about this now in conclusion, when you are now dealing with those H parameters. Is it the precision method or the approximation method? But they need you first to understand these calculations separately as they are. This will be a first question, maybe it's an exam. 3.1, they will give you to calculate this. 3.2, they will need you to use these values now in the calculation of the H parameters. So you must be able to understand these calculations before we talk of the H parameters. So that's what you had, guys. Till we meet again.